Hi, today we're going to cover chapter 6 on the network layer. For the objectives of this chapter, you're going to cover the following, namely to explain how the network layer protocols and services support the communication across the data networks, how the routers enable what we call the end-to-end connectivity between the business network, and to select the appropriate device to route the traffic in the business network. And finally, and most importantly, to know how to configure a router with the basic configurations. So this chapter, this is the few points that we're going to cover. So for the network layer is actually a OSI network 3, layer 3 network. Okay, it provides the services to allow the end devices to exchange data across the network. In order to do this, it has to accomplish the 4 basic processes, namely the addressing and devices, encapsulation of data, routing of information, and finally the de-encapsulation of the data packet. So for network layer, there are many different protocols available. The most common one that we are using now is the IPv4 or IP version 4. This is going to be replaced by the new IPv6 or version 6 due to the depletion of the IP addresses. Other IP protocols that have been used so far are the IPX, the AppleTalk, as well as the DECnet, which are all legacy protocols. So let's take a look at the components of the IP packet in a TCP/IP protocol. So in general, the IP packet consists of what we call the header, and the data is actually broken up into different segments. So what happened is, in order to transport the information from one end to the other, we have to break it up into smaller parts known as segments, and these are appended with the IP header so that they know how to reach their destination. So in general, the IP connection is connectionless, meaning that no connection is established before sending the data packet. It is actually what we call a best effort transmission, which is actually unreliable because there is no guarantee. Okay, there is no way to guarantee the packet delivery. So it's something like what we call the try your best. And finally, it is actually independent of the media, meaning that it can actually travel through the Ethernet wire or through the Wi-Fi network. So let's take a look at what we mean by the IP connectionless communication. So assuming you have a scenario where you have to send a letter to the destination, and when you send a letter into the post box, so what happened is that you will allow the postman to choose different ways to send your letter to the destination. Okay, so you do not know, okay, you are the sender, you do not know if the receiver is present or not. Okay, you do not know your friend is in your house or not, and you also do not know whether has the letter arrived at the destination, and you also do not know whether the receiver, your friend, has already opened up and read the letter. On the other hand, the receiver also do not know when is your letter going to come. So this is essentially what we call the connectionless communication, because in between the connection from the sender to the receiver, there is no way to know how to reach the destination or whether the status of the letter has reached the destination. Let's take a look at this characteristic of the IP protocol known as the best effort delivery. So what we mean by best effort delivery means that the IP protocol will try its best to send the packet from the source to the destination. Okay, so what happened is, assuming you have 3 packets from the sender side, So these 3 packets are sent through the network in different paths and reach the destination. But the problem is the IP protocol may end up having some packets lost on the way. Okay, and these packets are not guaranteed by the IP protocol. So in order to cover this management of tracking and ensuring the delivery is actually handled by other protocols in different layers. So the next characteristic of the IP protocol is what we know as the independent media. So what we mean is that from the transmission side, the sender will send the packet into the network, and as the packet passes through the network, it will pass through different types of wires or cables, such as your Ethernet cable, your serial cable, your optic fiber cable, or even your wireless network. So in short, it will travel through many different kinds of the physical network media in order to reach the destination. So let's take a look at this term known as encapsulation of the IP packet. So when we have the packet coming down from the transport layer, which is your layer 4, so when the data comes from the transport layer, it contains what we call the segment header together with your data itself. So as it passes through the protocol and it reaches the layer 3 or your network layer, so the network layer will actually append the IP header together with the segment header as shown in this diagram over here. So the IP header will be appended to the front of the segment header and the data itself, and the IP header will contain information such as your destination IP addresses or the source addresses and so on. So this is a example of the IPv4 header. In short, you contain the following information such as your source IP address, your destination IP address, the total length of the data, and so on. The IPv4 header contains such things as the checksum for the header in order to check that the data is actually valid, and it also have other header information such as your flags and fragments offset to allow the packet to be arranged in the correct order when it reaches the destination. So the main problem about the IPv4 network is that it is actually going to be depleted because we are going to run out of IP addresses, and the internet routing table is getting way too large, and when the internet routing table is too large, it will actually slow down the network. It will slow down the network, meaning that your network is slower and slower by the day. And the IPv4 also have some technical issues such as the unable to connect end-to-end connection between the different end devices. So these are the disadvantages of the IPv4 protocol. So the IPv6 is meant to overcome the shortcomings of IPv4. It will have increased network space. It will allow improved packet handling and eliminate the need for the network address translation table, okay, which we will explain to you later. It will also allow the network security to be integrated in the packets. So just a show of example, the IPv4 addresses have total of 4 billion addresses, but for IPv6 addresses you have a total of these 340 undecillion addresses. Okay, when we actually compare the IPv4 and the IPv6 headers, these are the comparison. So on the left hand side, the IPv4 header consists of many different fields such as your types of service, your total length, and so on, time to live. And on the other hand, the IPv6 header on the right hand side is very much simplified compared to the IPv4 header. It only consists of a few fields and mainly for the source and the destination addresses. So the IPv6 header, if we take a look in detail, it consists of the following: the version number, the traffic class, and payload length, and so on. So the next topic we're going to cover is what we call the routing. So before we actually proceed, we are going to explain this term known as routing. So in general, routing is a technical name in networking. How we describe it as how we are going to send the data from the source, okay, from the source to the destination. Okay, it means that you have many different paths. Okay, you have many different paths to reach the destination, but which path is the best? Okay, which is the best path to send? Okay, and best path, you have different criterias that you have to decide, namely your, for example, the data speed of the path speed, and you also consider other criteria such as your reliability of the path, and so on. So this is a generic overview of what we call routing. Okay, the routing in general consists of the transmission of information between different networks. So in networking term, we have a specific word known as the packet forwarding. So this means that how to forward the packet from the source to the destination. And in general, when we actually forward the packet across different networks, we have to pass through devices known as the routers. Okay, so the router is actually a equipment that is the main guardian of the network. So in this case, the R1 router is actually the guardian between the two networks, 192.168.10.0 and the other remote networks outside. So because that it is a known guardian, there is a technical term used to describe this guardian, which is known as the default gateway. So the default gateway is actually a technical term to describe this router that is sitting at the border of the network over here, and this router will be the gatekeeper or the guardian to ensure that the information coming in and going out of the network is correct. So the default gateway, in that the hosts must maintain their own routing table so that the network packets are transmitted to the correct destination network. So the network table typically contains the following information, such as your direct connection information, the network route, and the local default route. Okay, so let's take a look at how the router forwards the packet across different network through the router. So in this case, we have the following. The R1 router over here is actually directly connected to three networks. The first network is this 192.168.10.0. The next network is this 192.168.11.0, and the third network is this 209.165.200.224 network. So these are the three directly connected networks to the R1 router, and for the R2 remote router, you have other networks that is connected over, shown in the diagram. So from the IPv4 router, the CISCO router, we can actually view the directly connected networks, and this is the command that we will see when we actually show this on the network over here. Okay, so in short, the network is actually showing the following. When we type in the command show IP route, we will be able to see the directly connected networks as shown in the routing table over here, and these are indicated in the output from the show IP route command. So to zoom in on the routing table, we can actually see the following. So when we zoom into the routing table as shown in the diagram earlier over here, so the statement that actually shows the directly connected entries, this is how it looks like. When we have the left hand side, the part A, you have two different values, namely the C or the L. So the A shows the how the network is learned by the router. In C, it means that it is actually directly connected to the network. The network name is 192.168.10.0/24, and it is through this interface known as the gigabit Ethernet 0/0. So this interface is actually represented in the diagram over here, and this R1 router learns of this network in the routing table over here. Okay, so for the part B is the destination network, how it's connected, and C shows the interface. So for the remote network, it is actually illustrated in the routing table in the following way. So for the remote network through R1 itself, the remote network we are going to look at is this 10.1.1.0 network. So the entry in the routing table is shown in the following way. You have the remote network address 10.1.1.0, which is here, and it is actually connected via the 209.165.200.226 interface, which is shown over here. Okay, and you have other information such as your 90 slash a number below, which is actually represented by the routing protocol, and finally you also have the information such as your 0000 interface, which is actually the exit interface from the router itself. So these are the information that you can gather for the remote network in the routing table. So the routing table also shows what we know as the next hop address. So in this case, you have the router R1, and in order to go to the remote network over here, the 10.1.1.0, you have to pass through a router known as R2. So the R2 router is your next hop address. So the next hop address in this case is actually this 209.165.200.226. So this is your next hop address. Having seen the router routing table, so let's take a look at what exactly is a router itself. So a router is essentially a computer that actually is its own central processing unit or the operating system. And the router have many different kinds of memory, namely the random access memory, the read-only memory, and so on, NVRAM, and also the flash. So the purpose of each kind of memory are shown in the table below. So inside the router, if you open up, you will actually be able to see the different parts of the router similar to a computer. You have what we call the power supply, and you also have a shield for the wireless interface card. You also have other devices like your fan to prevent overheating, your SD-RAM, in this case operating like a computer, your NVRAM, non-volatile RAM, your CPU, your processor, and your advanced integration module over here. So if you look at the back plane of the router, you actually have some interfaces. In this case, the router over here have the following interfaces: the auxiliary ports, the LAN interfaces, USB ports, and different kinds of ports for different kinds of cables. You also have different slots, like in this case the EHWIC slots or the flashcard slots, for you to actually add the additional functionality to the router. So in order to connect to the router, you need to be able to connect to the different interfaces. So in this case, you can actually connect to a router through the WAN interface over here, or through the auxiliary ports, or through the LAN interfaces, your Ethernet ports. And you can also alternately control the router through the console port RJ45 or through the USB Type B console. So for the LAN and WAN interfaces, these are how it looks like from the back of the router. So for the Cisco IOS, is actually a name given to the router operating system. The Cisco IOS is actually varying on different devices, because different devices have their own different purpose and their different features. So what happened is that the routers in general for Cisco provides the following features. For addressing of network addresses, you have different interfaces. You can connect to your serial interface, or your Ethernet interface, or your wireless interface, and so on. You can also provide what we call the data packet routing, and it will provide the security for the packet and also some form of QoS, quality of service, and some resource management features. So when the router boots up, it actually goes through the following procedure. In the flash, it will actually read the iOS image, and the iOS image or the operating system will be loaded into the RAM, and at the same time the setup of the router is actually loaded through the startup config in through the running config. So this startup config is actually a set of commands or settings that will actually reside inside the router, and they will be loaded onto the router so that the router will know how to operate itself when it powers up. When the router powers up, it will actually go through the similar process like a computer known as the BOOTUP process. So in the router BOOTUP process, it will do the following. For the read-only memory, it will perform what we call the power on self-test, or POST. POST is actually what we call the power on self-tests. Okay, so upon doing the power on self-test, it will actually detect whether the router has the features available, such as your RAM, is it working properly, or your flash, is it working properly. If all the hardware features are working properly, it will go on to perform what we call the ROM bootstrap, and loading the bootstrap, it will continue to load the operating system, the Cisco iOS or Internet Work Operating System, through the flash or through the TFTP server. And upon loading the operating system, it will next proceed to load the configuration settings. So these are a set of settings that resides inside the router. Then this information can be loaded through the NVRAM or through the TFTP server or the console, and this configuration file is loaded, and after everything is completed, it will be entered into the setup mode as shown over here. Okay, so how we actually see the output of the router boot up, you can actually type the following command known as the show version command. So the show version command will show you the information regarding the router hardware, such as your router software version number. your version number, your software version number, and it will also show you the different information such as your router software name, and also the amount of memory available, the amount of memory available, and also it can also show you the different kinds of interfaces available, okay, so the different kinds of interfaces and so on. And it will also show you the different features that are already loaded into the routers, such as these features. So in short, it will be able to summarize the hardware configuration of the router itself. So let's take a look at the last part on how to configure a Cisco router. You will do more of this in your practical lab. So these are the basic steps that we will run through on how to configure the router itself. The main thing is to actually enter what we call the configuration mode. So from the user exec mode, so this is your user exec mode, you will enter what we call the privilege exec mode. So the privilege exec mode is here. You enter your privilege exec mode. So from the privilege exec mode, you will go into the configuration of the different router features, such as your host name inside your global configuration mode, and you can also configure different things such as your passwords, which is you will cover in the lab later on. You will also configure other stuff such as your banner, okay, banner of the day, the message of the day, banner or message of the day, banner, and so on. And finally, you can also back up your configuration. You can actually back up your configuration into your startup config. Back up your configuration. After setting up the router itself, you need to be able to configure the router to connect to other LAN devices. And to connect to other LAN devices, you have to connect through what we call the interfaces. So in the router itself, as shown on the diagram over here, okay, your R1 needs to configure to connect to other devices such as your other switches. In this case, this is your switch. Okay, you also need to be able to connect to other devices such as your other neighboring routers and so on. So all these connections need to go through what we call the interfaces. So all these interfaces are essentially your cables over here. So to configure your interfaces, you have to type a series of commands which we will not go through now, but essentially we will configure the interfaces so that it will be able to connect to the different devices over here. In this case, the red part is to configure the connection to the switches and so on. So the connection of the interfaces have to be verified. So in this case, the main way to verify our interface configuration, that means we want to test whether the interface is working or not. Okay, so how do we test or verify the interface is working or not? We will always do this thing called the ping test. So in this case, we will ping the destination address. So in this case, we will actually ping the destination address of this remote router over here, and we will see whether the connection is successful. So in this case, when it says success rate is 100%, it means that our connection is successful. Alternatively, we can also see our connection through the other commands such as your show IP interface brief command, and you will be able to see whether the connection status of the different interfaces over here. So in this case, both the status and the protocol is valid for the gigabit Ethernet 00 and 01, so they are working, and the other side, the 0001, is not completely working because it is administrative down over here. So we also like to configure what we call the default gateway in the router network. So in certain networks, you do not need to have a default gateway. So for example, in this case, you have the network over here on the left hand side. The network that passes through PC1 to PC2, you do not need to have a default gateway, because the device over here, this device is the switch. The switch will be able to do the necessary transferring of information between PC1 and PC2 within the LAN itself. However, for other networks such as this network over here, you have to pass through the different different VLANs in the different switches. So in short, you need to pass through a router in the center over here. So this router will be the default gateway, and you need to configure your router to recognize the network between the PC1, PC2 and the PC3, PC4 over here. So you can also configure the default gateway on a switch. So in general, you can also set the switch 1 in this case to be able to reach the administrator of the 192.168.11.1, which is over here, so that the R1 or the administrator, in this case this is your administrator, will be able to access the remote network effectively and for controlling purpose. So from the administrator point of view, the administrator in this case, which is over here, administrator or the controller of the network, the administrator can simply configure the default gateway. In this case is 192.168.10.1, so default gateway to this R1 router over here, so that he is able to control the remote network from another network. So in short, this layer 3 network layer is, you have actually look at the OSI layer 3 network layer, that it can provide the data exchange between the end devices. So to recap, the end devices refer to your different computers or your routers or your, no, not routers, sorry, your computers or your PDAs and so on. So the network layer also uses the 4 processors such as your IP addressing. It uses the encapsulation and routing. The current network router uses the IPv4 network layer protocol, but it will soon be superseded or replaced by what we call the IPv6 because of the lack of IP addresses and for better routing efficiency and so on. So the network layer is responsible for routing. So as we have mentioned earlier, routing is actually a process to find the best way to the destination. So routing is actually to find the best path or the best way to your destination, and the best way may not be the shortest way. It will also depend on other factors. So we can also configure the hosts with a routing table so that the packets will know how to go to the correct destination network. And in events that the packet are lost, you will always have what we call the default route to reach to the default gateway. So the default gateway is essentially the IP address of a router to the local network. And when the router on the default gateway receives the packet, you will examine the destination IP address to try and find the destination network. So the important thing of the router is how it handles the routing table. And the routing table in a router contains information about the different connected routes or to the different remote routes. So if no routing entry exists, meaning that the router must be able to send to the default route, or it will simply discard or throw away the packet. So the routing table can also be configured the entry manually through static routing or through different routing protocols. And finally, for the routers to be reachable, the router interfaces must be configured. That's all for this chapter. Thank you.